All right, this is the question number 1. This is based on the match the column. We have to match the entries in column 1 to column 2. This is from the chapter of electromagnetic waves. Here we are to mark out the uses of the different radiations. So UV rays are used for LASIK eye surgery. You need to refer to your textbook for this. This information is given in NCERT. Infrared rays, they are used in physiotherapy. X-rays are used for the treatment of cancer, and microwaves are used for the aircraft navigation. So the answer is R, P, then X-rays will be Q and S. So R, P, Q, S, R, P, Q, S. So option 2 is the correct answer. Next question. So we are given that during an adiabatic process performed on a diatomic gas, 725 joule of work is done on the gas. So work has been done on the gas. So if I use the formula Q is equal to delta U plus W, W will be minus 725 joule, because in this formula, W is the work done by the gas. Since we are given work done on the gas, so it must be taken with a negative sign. We want to find the change in internal energy, and we are given that is an adiabatic process. So adiabatic process means Q is 0. Therefore, delta U must be equal to negative of the work done by the gas, and that is negative of minus 725. So answer is plus 725 joule. So option 2 is the correct answer. Let's go to the next question. Here we are given two balls which are projected with equal speed. One of them at an angle of 30 degree and the other at an angle 60 degree with the horizontal. We want to find the ratio of maximum heights. So this is based on projectile motion, and in projectile motion, if we throw a ball at a speed u at an angle theta, then the maximum height attained is given by u squared sine squared theta by 2g. So we want to find the ratio of the maximum height. Now, while calculating these questions, you have to understand whether you have to find h1 over h2 or h2 over h1. So you just notice that first ball is given at 30 degree, other at 60 degree, and we have to find the ratio of the maximum height. So if nothing is mentioned, we will take the order that first ball is to second ball. So we have to calculate h1 over h2. So h1 will be u squared. Let's keep it u because it is same. So u square sine squared theta 1. And when I divide it by h2, I'll get u squared sine square theta 2. This 2g will cancel. U square will also cancel. So sine squared theta 1, that is sine squared 30 degree divided by sine squared 60 degree. So that will come out to be 1 over 3. So answer is 1 by 3. Option 3 is the correct answer. You might mark option 2 if you don't choose the correct order. So be careful with the order. Okay, we want to find the ionization energy of the second excited state of lithium 2 positive. So ionization energy of second excited state means in lithium atom, electron is already in the second excited state. Second excited state means it has jumped from n is equal to 1 to n is equal to 3 already. And now we want to send it to infinity. Ionize means we want to remove that electron. So we want to find this value. For that matter, we need to write the energy of the electron in the nth orbit, and the general formula is minus 13.6 z squared over n squared electron volt. This is the energy of the electron in the nth orbit. When the electron goes to infinity, its energy is 0. So amount of energy required would be the final energy minus the initial energy, and that will be plus 13.6 z squared by n squared electron volt. Note that this 13.6 is the value which we will obtain from this information. Actually, it is given that ionization energy in ground state of hydrogen atom is 13.6 electron volt. So it is that parameter which comes over here. Now for lithium, Z is atomic number 3, and we are given 3 because of second excited state. So if I put Z as n and 3, this becomes 13.6 into 1. So answer is 13.6 electron volt. Fourth answer. Next question, question number 5. In this question, we are given a ball of mass 1 kg. It is hanging from a string of length 1 meter, and the string can withstand a maximum tension of 400 meter. So the idea is we want to find the maximum speed that should be given to the ball. So the maximum speed that should be given to the ball, that means we have to have the condition that tension should be less than equal to 400 Newton. Now, when we throw this ball, it will start moving in a circle of radius r is equal to 1 meter. The forces acting would be mg t, and the ball, since it is moving in a circle, it will have an acceleration u square by r. So I may write Newton's second law as t minus mg is equal to mu square by r. That gives you the value of tension as mg plus mu square by r. Now this has to be less than equal to 400 Newton. We'll fit in the values. Mass is 1 kg, g, let us take 10 plus 1 into u square, r is also 1. This should be less than equal to 400. That gives you u square should be less than equal to 390. So u must be less than equal to square root of 390 meter per second. So the maximum value is 390 meter per second, square root of 390 meter per second. Option 1 is the correct answer. Okay, another question. This is again on the match the column type based on dimensional analysis. Not dimensional analysis, you just have to find out the dimensions. Torque. Torque is force into distance. Force is mass into acceleration. So mlt minus 2 into distance L. So it is ml2 t minus 2. So A goes with Q. So I think 2 and 4, one of them must be the answer. Now let's talk about stress. Stress is force upon area. Force is mass into acceleration. Area is L square. So this becomes ml minus 1 t minus 2. So it matches with P. Alright, this also. Anyways, let's check the next one. Pressure gradient. Pressure gradient is dp by dx or dp by dy. Basically, gradient means how things change in space, like potential gradient dv by dr. So pressure gradient is dp by dx. So pressure over length. Pressure is same as stress, force upon area dimensionally. So ml minus 1 t minus 2 divided by l. Dx is length. So this is ml minus 2 t minus 2. This goes with r. So 2 must be the correct answer. Still, let us check the angular momentum. Angular momentum is mvr. M is mass. V is velocity. Lt minus 1. R is radius. That is length. So this is ml2 t minus 1. ml2 t minus 1 s. So yes, second is the correct answer. Okay, let's go to the next question. Question number 7. The equation of two simple harmonic motions are given by this. And we want to find the amplitude of a resultant SHM. Resultant SHM means we want to superimpose both these SHM and then find the amplitude. This one is already interpreted as a single sine function. We'll have to convert this into a single sine function. So let's do that. So we have y2 is equal to 5 times of sine of omega t plus root 3 times cos omega t. This is a very standard transformation. You take 1 here and you can say 1 is equal to some a cos phi and root 3 is equal to a sine phi. That is the standard way of converting any expression of this into single sine or cosine function. If I square and add them, I'll get 4 is equal to a square. So I'll get a is equal to 2 and I'll get y2 is equal to 5 times. This is 2 sine omega t cos phi. I have replaced 1 by a cos phi and root 3 I will replace by a sine phi. So 2 cos omega t sine phi. Now you can see that I can take 2 common out of this and this becomes sine a cos b plus cos a sine b. So sine of omega t plus phi. So y2 becomes 10 sine of omega t plus phi. I need to find phi also. To find phi, I'll divide them. So if I divide them, so this equation 2 and equation 1, so root 3 over 1 is equal to tan phi. So tan phi is root 3. Tan phi is root 3, that means phi is 60 degree. Or phi could also be in which other quadrant tan phi is positive? So third quadrant. So answer could be in third quadrant also. But if you look at these two expressions, both sin phi and cos phi have positive values. So we'll take first quadrant only, 60 degree, that is pi by 3. So this is 10 sine of omega t plus pi by 3. So this becomes actually very easy because this y2 is 10 sine omega t plus pi by 3. Y1 is already given to be the same 10 sine of omega t plus pi by 3. So when I add, I'll simply get 20 sine of omega t plus pi by 3. Now you can see that this is SHM with amplitude 20. So the answer is option 2. Okay, let's move on to the next question. So we have a projectile which is thrown at 60 degree with the horizontal at a speed 40. Projectile 2 is thrown with the same speed for same range, but at different angles. We want to find the sum of the height. So both are projected with same speed of 40 meter per second. Let's call this speed as u and theta. Then height is u squared sine squared theta over 2g, and range is u square sine 2 theta over g. Now for same range, we should throw at complementary angles. That is, one of the angle is theta, other must be 90 degree minus theta. You can check by substituting. If I replace theta by 90 minus theta, I get u square sine squared 90 minus theta over g, which makes it u square, not sine square, sorry, this is sine twice of sine 2 times 90 minus theta over g, and this is sine 180 minus 2 theta, and sine 180 minus 2 theta is again sine 2 theta, so we'll have the same range. That means one of them is projected at theta and other one is projected at 90 minus theta. For the first case, range will be u square sine square theta by 2g. For the second case, I will replace theta by 90 minus theta. So u square sine squared 90 minus theta by g, and this is cos squared theta by g. So if I add h1 and h2, I'll get u square by 2g into sine square theta plus cos square theta, which is 1. So u square by 2g. So you simply have to solve u square by 2g, that is 40 squared by 2 into 10, and that makes it 1600 by 20, 80 meters. So answer is 3. So you see two questions are asked on quite a similar concept. So this is an important point to remember, that for complementary angles, you will have same range, theta and 90 degree minus theta. Let's move on to the next question. A body has a weight W on the surface of Earth. We want to find the weight at a height, be careful, at a height which is 9 times the radius of Earth. So first case, we are at the surface of Earth. So distance from the center of Earth is r. In the second case, we are at a height 9 times the radius of Earth. So the distance from the center becomes 10r. The weight over here will be m times g. Weight over here will be m times g prime. Now g prime, g will be gm over r square at the surface of Earth. And when the distance becomes, say, small r, then acceleration due to gravity will be gm by small r square, which is gm by 10r whole squared, which becomes g by 100. So the acceleration due to gravity becomes 1 by 100 times. So weight also becomes 1 by 100 times. So option 1 is the correct answer. You see, there is an option given W by 81. Some of the students may make a mistake, and instead of taking the distance as 10r, they may take the distance as 9r. In that case, they will get 81. So there is a probability of making mistake. So be careful. Answer is first option, W by 100. Okay. Question number 10. This is a very interesting question. A wire is first coiled in n circular turns and a current is run through it. Now the same wire means same length of the wire, is again coiled into n circular turns and same current is run through it. If B1 and B2 are the magnetic field, we want to find the ratio. We know that the magnetic field at the center of a circular loop is mu naught times I by 2r, and if there are n turns, it is mu naught ni by 2r. So if you don't focus on the idea that we are using the same wire, you may end up getting a wrong answer as B1 by B2 is equal to n by n, which is given as one of the option, but it is wrong. Because when we use the same wire and we coil it into different number of turns, the radius will change. Length will remain same. So suppose I have n turns of radius r, then the total length of the wire is n into 2 pi r. In the second case, I have capital N number of turns and let us say the radius is n into, capital R. So the length is same. Now magnetic field is mu naught n I by 2 r. Let us replace r with L over 2 pi n. So I'll get B is equal to mu naught n I over twice of L by 2 pi n. That makes it B is equal to mu naught n squared pi I by L. Now length is same, current is same, so B is proportional to n squared. So if B is proportional to n squared, then B1 by B2 will actually be equal to n by n whole squared. So answer is option 2, not 3. Okay, that was a good question. Let's go to the next question. Suppose we have a medium, we are given Young's modulus, we are given density, we have to find the speed of sound. This is a direct speed of sound. This is a direct formula based question. Velocity is a square root of modulus of elasticity divided by density. So modulus of elasticity is 3.2 into 10 to the 10 and the density is 8,000. Note that all the values are in SI units. So no worries, we can simply solve it. And this solve, okay, let's solve it. So this is 32 into 10 raised to power 10 over 8 into 10 raised to power 4. 3 zeros already there. I replace this decimal by another 10. So this is 8 4s are 32. So root of 4 into 10 to the power 6. That is 2 into 10 raised to power 3 meter per second. So 2000 meter per second is the answer. Okay, next question. When a current of 4 ampere is made to run through a resistance of R ohm for 10 seconds, it produces heat energy H. This is based on Joule's heating. Heat produced in a resistor is I square R times delta T. Now we are changing the current. We are keeping the resistance same and time is also same. So resistance is also same, time is also same. So that means heat is going to be proportional to I square. So the second case heat, let's call it as H prime, and initial case heat, this must be equal to I prime squared divided by I squared. So it is 16 over 4 squared. So answer is 16. So H prime over H is 16. That means H prime is 16 times H. So 16H is the answer, first answer. Papers of physics are quite easy. It is more based on calculation, simple calculation. So those of you who are having good accuracy and the patience to read the question carefully, they are going to get very good marks in this. So just be careful in solving. Let's go to the next question. We have an inductor of 5 millihenry in an AC source, and the potential voltage is given as 268 sine 200 pi t. We have to find the inductive reactance. So inductive reactance is XL and it is simply omega times L. And omega is this. We know that V is V naught sine omega t is the standard equation. So omega is 200 pi. So this is 200 pi into L is the inductance. Inductance is given to be 5 millihenry. So this becomes 2 into 5, 10, 1000. So pi. So answer is pi ohm. This is inductive reactance. The units would be ohm. So answer is pi ohm. Fourth answer. Okay, let's move on to the next question. This is another standard question, very common. A lens of refractive index 1.5 and focal length 15 centimeter here is submerged in water. We want to find the change in focal length. Focal length is given by this formula. When something is in air, when a lens is in air, it is mu of the glass minus 1 times 1 over R1 minus 1 over R2. This is the famous lens maker's formula. This is for air. And if I submerge this in water, then in place of mu glass, we have to use mu glass divided by mu water. Minus 1, 1 over R1, minus 1 over R2. Let's divide these two equations. So 1 over 2 I will do. So I'll get F water over F air. And that will be equal to mu glass minus 1 over mu glass minus mu W by mu W. So mu W will come here. So if I fit in the values, I'll get mu glass is 1.5. Let's write it 3 by 2. So this is 3 by 2 minus 1 into 4 by 3 over 3 by 2 minus 4 by 3. That is 1 by 2 into 4 by 3, 2 by 3, and this is 3, 3s are 9 minus 1, 1 by 6. So that makes it 4. So the focal length in water becomes 4 times the focal length in air. So focal length in the water becomes 4 times the focal length in air, which is 15 centimeter. So this makes it 60 centimeter. Now be careful. Over here, there is a high probability that after getting this answer, you will quickly mark 60 centimeter. But we are not asked the final focal length. We are asked the change in focal length. So change in the focal length will be the new focal length minus the initial focal length. So 60 minus 15, that is 45 centimeter. So answer is 45 centimeter. You see, they will set up small traps in the questions to make you commit mistakes. So be careful. Answer is 45 centimeter. All right. Question number 15. In a moving coil galvanometer, the number of turns are increased to increase the current sensitivity by 50%. You have to find the percentage change in voltage sensitivity. The current sensitivity of a moving coil galvanometer is the deflection produced per unit current, and it is equal to NBA over C, where N is the number of turns, B is the magnetic field, A is the area of each turn, and C is the torsional constant of the suspension fiber. Now we are changing the number of turns to change the current sensitivity. Before I solve this, let's write voltage sensitivity. Voltage sensitivity is theta over V. V is the voltage applied, and V can be written as IR, and this is current sensitivity divided by R. So this is NBA over R into C. R is the resistance. Now this question is based on a very important idea that when you increase the number of turns, maybe let us say you double it. That means you are using double the length of the wire. And we know that resistance of the coil will be rho L over A, where L is the total length of the wire. So if I double the length of the wire, then number of turns, if I double, then length will also get doubled. So N and R, N by R will remain same. So that is a very important point. If you change the number of turns to change the current sensitivity, there is no change in the voltage sensitivity. So answer is no change. Third. Very good question. Okay, let's move on to the next question. In a series RLC circuit, we are given resistor, we are given XL, we are given XC. The source voltage is this, and the peak current. So peak current will be the peak value of voltage divided by impedance, and impedance is Z. Peak voltage we are given 2500, and Z we need to calculate. For a series LCR circuit, this formula you should remember. It is R squared plus XL minus XC whole squared. So we fit in the value. R is 80. XL minus XC will be 100 minus 40. That is 60. And this value will come out to be 100 ohm. So that is 100. And therefore the peak value of current would be 2500 divided by 100. And that is 25 ampere. So the answer would be 25 to this question. All right, next question. Okay, this is a good question, somewhat calculative and some tricky also. We have two discs of same mass, radii R1 and R2. Their thicknesses are given and densities are given. Density ratio is given. We want to find the ratio of their moment of inertia about diameter. So we have to find I1 by I2, where I1 and I2 are the moment of inertia about the diameter. Now in this question, you don't need to remember exactly the formula for moment of inertia about a diameter. The idea is, since both are same shape of object, two discs, so moment of inertia about their diameter must be some multiple of mr square. So m1 r1 square times some multiple. I know that multiple, it is 1 by 4. Moment of inertia of a disk is 1 by 4 mr square. But what I am saying is, you don't need to remember this for this particular question. So this question is actually about calculating the ratio m1 r1 square to m2 r2 square. Now we are given masses as same. So masses will cancel out. So the answer should be r1 square by r2 square. But you can see there is no information given on the radii. The radii are simply written r1 and r2. But we are given thickness and density. And we are given same mass. So let's equate the masses to find the ratio of R1 and R2. We can write mass as density into volume. Density, let us call it as D. Volume is, for a disk will be, volume will be pi R square into thickness. So let's equate them. So D1 into pi R1 square T1 must be equal to D2 pi R2 square into T2. So from here I can find the value of R1 square by R2 square. Note that the small r, capital R represent the same thing only. So R1 square by R2 square will be D2 T2 by D1 T1. Now we are given the density ratio. D1 over D2 is given to be 3:1. Be careful about this. As I said earlier also, you have to be careful of the order. So first disk has radius R1, second R2. So density ratio 3:1 means first to second. So 3:1 is D1 by D2. So D1 I will put as 3D2. So I'll be left with 3 here. And T2 is 0.5 and T1 is 1. So this is 1 by 6. So R1 square by R2 square is 1 by 6. So I get I1 by I2 as 1 by 6. And they are saying that if this is 1 is to x, find x. So x is 6. So that is the answer. This was a good question. Let's move on to the next one. There is a body which is moving horizontally with initial speed 20. Due to friction, the body stops after 5 seconds. Mass is given, coefficient of friction is x by 5. You have to find x. So the idea is, there is a body, some block which is sliding on a rough surface. and it stops after 5 seconds. So in a time interval of 5 seconds, velocity becomes 0. I can find acceleration from here. Using v is equal to u plus at, I'll get acceleration as minus 4 meter per second square. Now this acceleration is caused by the force of friction. So let's find the force of friction. The weight of the body is mg. There will be a normal and there will be a kinetic force of friction, which is mu n. Since n is mg, therefore friction would be mu mg in the backward direction. Therefore acceleration will be minus, let's divide the force of friction by mass. So I'll get acceleration as minus mu g. So all you need is to put the acceleration as 4 in this is equal to minus mu into g. So you'll get mu is equal to 0.4. But don't mark 0.4. Again, be careful. It says coefficient of friction is x by 5. Find x. So we equate this to x by 5 and we'll get x. So value of x will come out to be 2. We have to fill in 2. Okay, questions are easy, but there are a lot of small traps in there. So be careful, otherwise you will end up making mistakes and lose marks. Okay, next question. A ball was dropped from a height of 20 meter. Find the height up to which it will rise after the collision. After the collision. So after only one collision we are talking about, we are given coefficient of restitution. So a ball is dropped from a height h. So it goes without saying that initial velocity is 0. So when it hits by energy conservation, its velocity will be root 2 gh. Or you may use v square minus u square is equal to 2s. Now, if the coefficient of restitution is 1/2, then it is going to rebound with the speed, which is 1/2 of root 2 gh. And now you want to find out up to what maximum height it rises. So again, suppose this is v prime, this is h prime, final velocity is 0. So 0 square minus v prime square, v square minus u square is equal to 2 into a. Acceleration will be minus g in this case. I wrote 2 twice, negative sign. So 2 into minus g into h prime. So h prime is v prime square by 2g. So v prime square by 2g will come out to be 1 by 4 times h. So if I put h as 20, this is 5 meter. I would like you to note this, that after first impact, the height will come out to be e square h. So I could have calculated the answer directly. After the second impact, let's call this as h double prime. It will be e square times h prime, and that will become e raised to power 4 times h. So first impact, you will get e square h. After second impact, you will get e raised to 4h. After the third impact, you will get e raised to power 6h and so on. So this is an interesting result. You may take a note on this. Okay, next move to the next question. Question number, there is no point of question number. These are memory based only. So a particle is in uniform circular motion with a time period of 4 seconds and radius root 2. We want to find the displacement in 3 seconds. So it is moving in a uniform circle with a period of 4 seconds. So that means it starts from some point A and it covers the whole thing in 4 seconds. So we want to talk about what happens in 3 seconds. So in 3 seconds, it must be able to cover up this much part. Total is 4 seconds. So it is equally divided. It will take 1 second, 1 second, 1 second, and 1 second. So it starts from A and ends up at B, and therefore this would be the displacement. This is R, this is R, this is root 2R. So answer is root 2R. So root 2 times root 2. Right? That is a nice answer. 2 meter. So 2 is the answer. Okay. This is a very nice question. Very interesting question also. Take a serious note on this. This is similar to kind of questions which are sometimes asked in JEE Advanced as well. So we have two wavelengths, lambda 1 is equal to 600 nanometer and lambda 2 is 800 nanometer. Both are used in YDSC, Young's double slit experiment. Their maximas coincide at certain location on the screen. We have to find the minimum separation between such a location and central maxima. So let's just have a quick look at the setup. So this is small d, which is given to us. This is capital D. This is a standard notation. This is also given to us. This is the location of central maxima. Now we want to find a position where maxima due to both the wavelength coincide. So the maxima is formed when y is n lambda d by d. Now we have to find the position where both of them have maxima. So let us say n1 lambda 1 d by d is the position where n1th order maxima of lambda 1 is formed. And this is supposed to coincide with some other maxima of the other wavelength. So what I'm going to do is I'm going to equate the locations of maxima. So I get n1 into 600 is equal to n2 into 800. And this gives me n1 over n2 equals 8 by 6. And we can reduce this to simplest fraction 4 by 3. Now you need to understand that this n1 and n2 are integers. So clearly the smallest integers which can satisfy this condition is n1 is equal to 4 and n2 is equal to 3. So the first time when the maxima is coincide is when n1 is 4. Now all you need is to find this value by taking n1 as 4. So 4 into lambda. Lambda 1 is 600 nanometer into capital D, which is 7, and you have to divide it with small d. Small d is 0.35 millimeter. So we can solve this. So this 0.35, I will break it out to make it 700. Then 35 to the 70. So this is 20. So 24, 20 into 4, 80. 80 into 6 is 480. So 48,000 into 10 to the minus 9 and 10 to the minus 3. That is into 10 to the minus 6. So that makes it 48 into 10 raised to power minus 3 meter. Okay, so we have to find the answer in millimeter. So this can be written as 48 millimeter. So the answer is 48. Be careful about the units. Answer is as in millimeter. So don't mark the answer as 0.048 meter. Answer is 48 millimeter. Okay, that brings me to the end of the question. We were able to collect these many questions. So I hope I have presented a nice solution to you and this session is useful to you. I would recommend solve all these questions rigorously. That will help you in your preparation. Thank you.